Hello everyone, welcome back. We are going through Kubernetes the Hard Way. This is part 3. Yesterday got through the etcd setup. Today hopefully we can get much further, as we had a bit of an issue with IP addresses. Let's get into it. So as a reminder, running from a MacBook to a Mac Mini. On the Mac Mini, we have a Vagrant VirtualBox Ubuntu machine, and on that we have LexiLexD, which has the Lexi list. We have 3 controllers, 3 workers, and HA proxy. So we have finished 07 bootstrapping etcd from the Kelsey Hightower series of Kubernetes the Hard Way. All right, so let's begin on bootstrapping the Kubernetes control plane. Let's see. So Google Cloud, we do not need that. All right, we are running these in parallel on the controllers. So we need to make the Kubernetes config folder within the etc. directory. Install the Kubernetes binaries. Again, this doesn't make sense to grab them all from... Oh, I just made that directory on the HA proxy, and that is definitely not where we want to be. Control B2. All right, let's actually create that directory on the 3 controllers. There we go. That's better. Now, let's grab those binaries. kubectl, scheduler, control manager, and API server. Getting those onto... Oh. Actually, this will be okay. Yes, because I'm going to do the LXC push. So let's come over here and file push, I mean. If we just come down to the bottom. Don't know where that nonsense came from. So we are downloading these 4 files into the Vagrant machine. We want to copy them to the controller. C file push. So for instance and controller 0, controller 1, controller 2, do LXC file push, the API server, the controller manager, the scheduler, and kubectl to instance root. Okay. So we can did we have a failure there that I missed? Ah, no, they just have an older date, not today's date. They have the date of the day they were downloaded. So, okay. So this will use LXC file push to push the 4 files into each of the 4 running containers, which are our controllers. We are going over to the controllers, and we see that our 4 files have been pushed. Okay, so we have those 4 files. Now it wants to change the mode to executable on the 4 and move them to user local bin. Okay. Make the var lib Kubernetes directory move these 4 files. Let's just make sure that they all exist. Okay, those 4 files. Yes, the 4 files exist. Oh. Check for these 2. Those 2 exist. And let's just double check that this file also exists. Okay, excellent. So we don't want to try to copy files that aren't there and then assume they're there and our configuration be invalid. All right. Now, internal IP. I believe we still have that. Oh, $sign in internal IP. Excellent. And so a reminder that this is how we were able to sign that. This may look a little bit intimidating, but it is just getting the IP address. IPA. So that gets all of the IP addresses. We then grep for inet space 10 dot. We strip off everything that's irrelevant, split it on the slash. So let's just go ahead and do this part. Well, we can grab all of this. So we've got everything up to the inet 10. Then we are going to replace everything from the beginning of the line through inet space with nothing. Then we are going to cut on the delimiter of /, and we only want the first field. And that gives us the IP address. So those are our internal IPs. So now we need to create the new API server.service. And we definitely have those nasty 10240 addresses, which fouled us up yesterday, or possibly the day before when they were created, but only discovered yesterday. And this is for the controller, so let's go up and grab our controller addresses. Oops. CD servers. All right, so we now have our 3 etcd IP addresses, which are also our controllers. We are going to cat that out through the end of the file, then tee it into, we don't technically need to do it with the T because this is running as root, but to avoid fouling something up accidentally, I'm just going to leave it as such. service cluster IP range. So this is where it is defining the Kubernetes IP range, I believe. All right, so we grab all of that. And this is for the service configuration. So we want to run that on all 3 controllers. Moving the manager. Let's make sure we have one of those. Oh, something happened with our copy paste before. We missed the EOF. So that was going to never finish because I was waiting for the end of file. That's better. And now let's just validate that we have this file. File exists. Okay. So we want to move this to varlib Kubernetes. Okay, cluster cider 10200. Was that the one we... 1032. I think that 10200 is that IP address that has fouled us up. I am not positive though. It's just, no, that's 10240. 200, I never can remember cider rules. So that is a class 16 on 10200. A /16. So that gets 200 through everything. So it would just be the last 2 octets. And this was 240. I'm just trying to make sure that we're not giving a Google Cloud address and that this is an internal ID and that is acceptable. So I think if I read more, this would make more sense that the cluster cider is for the entire cluster and the service is what gets exposed. So this is internal, so how the pods can communicate. That's what it appears to be. As I said from the beginning, if this all blows up, well, then we get a chance to try again. I think that's the whole point of Kubernetes the hard way. All right, so let's make sure the AKK, what is that? AL Kube Scheduler, that exists. So let's move it. Right now, scheduler, that should be fine. Let's just double check. So the first time I ran through this, not on stream, I did not give Lexi the pool for Lexi enough space and ran completely out of space before I got to the workers. Still 32 gig available, so looks good. So that was the Kube Scheduler. Kube scheduler. Kube scheduler YAML. Yes, YAML. Okay, so now let's do this one, which is the scheduler service. So we can start it, enable it. So I'm just going to again run these individually to ensure that if there is an issue, don't assume something. So enable it. Enabled, okay. Let's see if we can start this. Fingers crossed. Oh, that started quickly. How about that? So it says to allow up to 10 seconds for the Kubernetes API to fully initialize. All right, so to do that, well, let's just get a status of it, I suppose. It's running. Control manager running. And the scheduler is running. All right. Now, let's see. Enable health checks. So I am using HA proxy to proxy the actual connection to the Kubernetes controllers. So I'm just checking to see if it makes any sense to install Nginx here or not. It may make sense because that won't hurt. Well, let's just go ahead and do it. Just make sure it's not asking us to do it somewhere else. Okay, so this is to proxy pass. All right, yeah. Well, let's see, wait. Was it saying that that is already running? Let's just see. Let's ignore the certificate. And it's returning an OK. So yeah, let's go ahead and... Oh, we've updated recently, so we can just do an Nginx install. All right, so the config for the Kubernetes default service cluster.local. Here. Okay, come on. Install Nginx. All right, so where do we stick that into the local folder? So now moving it, enabling it. So moving that file that was created locally to the sites available, and then linking it to the sites enabled. restart Nginx and enable it so if we reboot, it will automatically start. So let's see if we run git component status with the kubeconfig admin.kubeconfig. So what's happening? Come on. Oh, how about that? Fantastic. So we have 3 etcd servers, the control manager, and a scheduler. Amazing. So to test the health check, so we are telling it the host we're using is this default service cluster local, which we installed, or not installed, but identified in the certificate that we generated. All right. Get an okay. Everything's looking good. Are back for kubelet authorization. Just taking a quick second to validate what is happening here. Commands in this section will affect the entire cluster and only need to be run once from one of the controllers. So when using tmux to synchronize panes, if you, so we do an ls here. Well, actually, so if we zoom in and then zoom back out, you can see that only controller 0 has been affected. So we'll zoom back in. So we need to kubectl apply the admin config with the -f. Let's just see what that is. I'm sure it's like a file. Oh, okay. So it's applying the file that comes in after we paste this in. Some odd looking syntax, but let me just look quickly. Just for, yes, so file name. And the file name being the file that we are creating. Definitely strange syntax. I mean, I've seen it before, but trying to figure out the proper way to pass that in can be odd. Okay. But that has been done. So bind the role. So what was that? That was the cluster role. So that is a role that is used for RBAC. And this is the binding that'll attaches to that role. Okay. Okay, let's see what we have here. All right, what are we going to want to do with this? So for the front end load balancer, that is going to be our HA proxy. So because of not using GCP and doing this on LexiLexD, I need to figure out what we want the result to be for us. First step, we're getting a public address. Well, let's just take this whole thing. All right, so this is let's just put this over in here. So we can make some changes. All right, the public address. Public address is HA proxy. So because we had defined that here, let's just dollar sign. I was just making sure I didn't misspell that. Oh, actually, though, but we're not doing this from here. We're doing this from probably the HA proxy. So what I think we need, just go ahead and grab the IP address. So the Kubernetes public address is our HA proxy address. All right, this is to create the health checks on a host. So I'm not that familiar with Google Cloud, so having to think through this a little bit. So obviously compute is compute, but in the HTTP health checks, so they're creating a health check named Kubernetes, and that health check has a description, a host, and a path. Then firewall rules we don't need to worry about at the moment because all of these are running internal to Lexi. So then there's a target pool for health check called Kubernetes. Then for the target pool, adding the 3 controllers and then forwarding the public address to the port for this target pool. So I think we need to set a new rule here in HA proxy. That may actually still be being edited. So we've got Kubernetes 6443 is already round robining to each of them based on IP address. So let's see. We're well, let's see. What's the verification? Verification is to go to the public address 443/version. So this may already be done for us. So 1080. So if we take this like this. So running this on a machine that has the ca.pem. Okay, we have a ca.pem here. I'm not convinced this is going to work. Holy crap, it worked. Oh, that's very surprising, actually. I just hadn't gotten a full grasp of the whole thing and just assumed it was going to fail. Let's see. I would just like to know which controller that's hitting. I wonder if we can check that easily. Don't want to spend too much time on it, but not etc. Var log. What do we have in var log? Anything? Flex the engine. Nginx, yes, of course. Oh, yes, that. So Nginx is proxying to let's tail that. So now if we come back to here and run that. No. Oh, because it's not proxying for health, right? It's proxying this time for version. So healths. Got an okay. Doesn't matter. I was just curious to see if we could tell where that was coming from, and I'm not positive where our logs are hitting for Kubernetes at the moment. Let's just keep looking. So I think we're good. So let's start on the worker nodes. We've got some time. All right. So we want to go to the workers. And install socat, contract, and IP set. Socat enables kube control port forward. Kubelet will fail to start if swap is enabled. I don't think swap should be on, but I'm not sure. Oh. Okay. Let's think about this a minute. This swap on is inside of Lexi's LexD, which is inside of Vagrant. Of course not. Etc. F a stab. Okay, fuse or fuse. So that's created by Lexi. I wonder if that will blow something up. Let's have a look. Okay, let's see what happens. Don't know. We might be blowing it up. No. Swap off, not a super user. Well, I mean, I'm root. Let's see what it has to say about that. Anything of value in here? I doubt it. All right, so we need to disable swap. That's just in Linux. Thanks so much. Okay. I had heard of other people doing this, and I did not expect to come across this issue. I had not completely finished, as I wanted to show all the bumps and bruises along the way. But I may need to do some more research. lexiconfig. So we may need to have the config on the Lexi controllers have swap off. Let's see if we move forward without doing that, what happens. First case, we'll already have the binaries. We can stop the. Now you know what? I'm almost positive that will end up causing problems. Let me just see if any of the notes I have over here have any of the any reference to the swap. Disable the swap. Okay. All right, let's do it there. I don't think the first time I read through this, there was mention of the swap. I think that's why I had not intended to have to worry about this. Let's go ahead and try this. Go back over to 0. So get those files. Let's see here. Oi, come on now. Here, here, here. Let's just do this. Oh, come on. Well, that didn't work either. Sometimes you spend more time trying to save time than you actually end up saving, I suppose. Okay. All right. Oh, wait. Is that? Yeah, okay. Just make sure that those file names are correct. Yeah. Okay, so we are going to, for each of those files, or LXC file push file to instance root. And the instances are worker 0, 1, and 2. So we push those files up. Wait for that to finish. Okay. Right, there's a load of files there. So let's make that set of directories. Make dir container D tars. Okay, those all look standard. Nothing of relevance to Google Cloud. Now, pool side range. So I wonder if that should be okay, the pod side range. Okay. All right. Let's see, did we mention some IP address? An IP address range. A service cluster. And then I thought there was one other IP address range in here. That we had just looked at. The 1032, the 8030s, 108030s, which are from Lexi. I don't think we've mentioned these anywhere. So let's go with wait, we did do the 10.200, didn't we? 10.200, because we saw a 16 /16. Right, where did we see that /16? Yes, that's what I was thinking. Right, so 200's a /16. That is for the control manager. Not right now. So we had a 16, which was that. 24, which is that. All right, so I've got some .0.0/24. One. 2. 0, 1, and 2. So the /16 is 10, 200, 00/16. The pod siders will be, well, they'll be broken if I use this one. Okay. 10, 200, 00, 10, 20. Okay. And we were here getting the pod. Wait. No, okay. I think I skipped a step there. What's that called? Pod solder. All right, here we go. So we got our pod solder. Actually, I wonder what that even... I mean, that's got to be... I want to see what that says. Curiosity. Doesn't say anything. I don't know. I suppose that's something that's only internal to GCP. Let's just make sure that come on, fingers. Okay. 001020. All right, so we manually assign that. That's inside of the /16. So a bridge with the subnet to the pod cider. Okay. We need loopback that for the CNI. So did it say what the CNI is? I mean, I kind of know, but just to describe it exactly. Container network interface. Yeah. Sure, so container network interface. And I knew it was networking, obviously. It's all about the IP addresses. But so we're configuring the CNI. Now we need to make sure that this exists. Yeah, just double checking that I am on the worker still. So the config.toml. Okay, so this is for container D. The container D service. Everything looks normal. So now let's just go hostname. Yep. So we're going to move hostname key to hostname pim, or move those two files into varlib kubelet. So let's just do this. First we'll echo that, and then we'll ls that. Oh, well, obviously that would have worked the same way. Haha, silly me. Let's just ls minus al. 1, 2, yeah, okay. And then, okay, that file's there too. And then CA's there. All right. Just being overly cautious. I was almost positive it was there, but it's bitten me before. So we're going to create the kubelet config. Oh, did I? No, okay, cool. Cluster DNS 32010. Did we already have a 32? I think we did. Yeah, okay. Whoa. 320, okay. All right, that's fine. Okay, the kubelet service. Move the, let's just double check again. Move that. Creating, yeah, there's that /16, which is what we expect. Okay. Kube proxy service. All right. Daemon reload. Daemon, depending on how you like to pronounce it. Okay, enable no fails. All right, moment of truth. Well, one of the moments of truth. All right, that is not all that surprising, unfortunately. Overlay not found in directory. This could 100% be because of the swap. Was it container D that it's swap? Okay. What is this? Oh, that's not the... That is not where I'm meant to go. Okay. And that must be related, right? Let's try running. Containerd failed. So just make sure we've got let's see. I don't know. I mean, we don't want to install Docker, I don't think. I'm not sure. This may need to wait until tomorrow. I'll try to do some research beforehand, of course, to make sure that you're not just sitting there watching me Google if you join or on the VOD. This was back in 2018. I don't know that it's necessarily still the same issue. Wait, here we go. Let's see what this says anyway. XX start pre. So if a spin mod probe overlay. So it looks like let's see what happens. Let's see what So that is edit, right? And then removing the exec start pre. So ugh. So bad. Editor equals them. Come on now. Editor them. Them? Yeah. Temporary file is empty. So if that already exists, that maybe we already created that. Is that what we did in system D, container D, service? Yeah, there we go. So we actually added the mod probe overlay ourselves. Let's just try removing it. No idea if this is a good idea or not. Let's do... having some issues with my keyboard layout, so I have to copy the hash symbol sometimes. Oh, yes. Let's just try container D. Running. Don't know if that's good or not. Let's go ahead and try kubelet and kubeproxy. Oh? Well, they started. If we just, can we get the status of all of them at once? That does. Failed to load. The kubelet is enabled and running. Was it kubeproxy that was failing? Or did it just need time to activate? You can ignore this message when kube something. Okay. Let's see. Now that we've gotten down here, so from controller 0, no, is it not names? Is it just namespace all? Well, dagnabbit. Okay, well, I'm out of time for this evening. But we have a good place to pick up tomorrow. Hopefully I can spend a little time trying to figure it out before then. So thanks so much for joining, and hopefully we get even further, but we did get further than I'd actually kind of thought we would. So that's something. Thanks for watching, and hope to see you again.